Today's lesson is 8-6, Comparing Fractions. We're in the Envision Volume 2 textbook on page 313. And we are going to use equivalent fractions to compare fractions. Solve and share. Juan read for 5/6 of an hour. Larissa read for 10/12 of an hour. Who read for a longer period of time? Explain and solve this problem any way you choose. You can select and use appropriate tools such as drawings, number lines, or fraction strips to solve. Show your work in the space below. All right, let's start with 5/6 of an hour. We're going to make this area model. And to make 5/6, it's easiest it's an even number, so I divide it in half. That's 2 pieces. I need 6 pieces, so this one has to be divided into 3s. All right, so I have 6. 1, 2, 3, 4, 5, 6 pieces, and we're talking about 5 of those. 1, 2, 3, 4, 5. So I've represented 5/6. Now that's Juan's reading, and now Larissa read 10/12 of an hour. I notice that my fraction is no longer 6, it's divided into 12ths. How do I get from 6 to 12? Yes, I multiply 6 times 2 to get 12. And so in doing so, that means that if I divide these in half, I'll now have 12ths. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've now divided my model into 12ths. And if 5/6 is written in 12ths, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are shaded because 5 times 2 equals 10. So Juan's 5/6 of an hour is equal to Larissa's 10/12 of an hour. That's the area model. We could have done the same thing with the number line model, which you're going to review with the visual learning video in a few minutes. I have fraction strips here. If we were in school, I would have some for you all to practice with, but you'll just have to look at mine. So this is a whole. This red one's a whole. And if we divided our whole into 6 equal pieces, this is what they'd look like. 1, 2, 3, 4, 5, 6. Remember, the denominator or bottom number of your fraction is the number of equal pieces of our whole. Now, if we divided the same whole, same size, into 12 equal pieces or 12ths, it would look like this. Notice how they line up. Notice that it takes 2 12ths to make 1 6. 2 12ths makes a 6th. And that's what we found out because we're dividing 6 or multiplying actually 6 times 2 to get 12, or 12 divided by 2 equals 6. So it takes 2 12ths to make up 1 6th, and that's what this area model showed. So we're going to use equivalent fractions when we compare them. We would say that these two are equal. Now, down here it says Carlos read for 8/12 of an hour. Did Carlos read for more or less time than Juan? Remember, Juan read 5/6 of an hour, which we determined is equal to 10/12 of an hour. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So he would have read for this amount of time, 10/12. And then Carlos read for 1, 2, 3, 4, 5, 6, 7, 8. Only read this much. So we can say this one's 8/12. This larger one here there are 10/12. That 8/12 then is less than 10/12. If we have the same number of equal pieces, we're really just comparing the numerators. 8 is less than 10 because we have less of those equal pieces. Now it'll be a little different situation if we have a different denominator, if our pieces are a different size. As you can see, 1/6 compared to 1/12 is not equal because we have bigger pieces with the 6. So we would not say that 1/6 equals 1/12, even though the numerators are both 1. All right, that'll be another lesson. So let's look at another example. We're going to skip 312 because you'll go over 312 with your visual learning video. And like I said, you're going to do a number line, and you're going to also talk about renaming your fractions to have the same denominator. Compare 3/4 and 6/10. Create an equivalent fraction for either 3/4 or 6/10 so that the numerators are the same. So 6 divided by 2 is 3. So 6/10 equals 3/5. And then we are comparing now our 3/4 not to 6/10 but to 3/5. So we see that 3/4 is greater than 3/5. When you divide a whole into 4 equal parts, each part is larger than when you divide it into 5 equal parts. So it sounds the opposite of what it should be. You would think that 5 is greater than 4, so 3/5 would be bigger than 3/4. But remember a pizza. Would you rather have 1/2 of a pizza or 1/3 of a pizza? So let me just show you my pizza. Here's 1/2 of a pizza. Here's 1/3 of a pizza. 3 is bigger than 2, but I would rather have half of the pizza, even though 2 is the smaller, because as a fraction, remember, the denominator is the number of equal pieces. So 1/3 of a pizza, which just means that our whole pizza has been divided into, we'll put some cheese pizza with that, so 1, 2, 3/3 versus it takes 2 halves to make a whole. 2 is smaller, but the half is actually larger than 1/3. So that kind of helps you see that you're comparing the numerators. The 3's are the same, but the denominators, 1 out of 4 pieces is actually bigger than 1 out of 5. Now looking at guided practice, do you understand? Mary says 1/8 is greater than 1/4 because 8 is greater than 4. So that's kind of what I was talking about up here. Is Mary's reasoning correct? As we just said, no, because we're talking about 1 out of 8 pieces. Let's look at a fraction strip on that one. There's 1/8, and 1/4 is really hard to see. It's yellow, and it's kind of difficult to see that. Here's a whole. Our wholes are the same. This is one whole, this is one whole. 1/4, 2/4, 3/4, 4/4. It's hard to see. Is 1/4 or 1/8 larger? Yes, 1/4 is larger. Remember, the more pieces that something's cut into, the smaller they become. So even though 8 is larger, 1/4 is actually greater. And that we would show in the pieces of pizza. Remember, 1/4 of a pizza, so it would take 4 of those to make a whole pizza. 1/8, it would take 8 of those. I would rather have 1/4 of a piece of pizza than 1/8. 1/4 is greater in fractions, right? Those two makes 2 of these eighths to make 1/4. So this is a no, and we could explain it that the pieces are greater size when the denominator is smaller. Now, do you know how for 2 through 5 write greater than? Remember, greater than is in the alligator mouth is to the left. The bigger number's on the left on this side. Less than or equal to. Use number lines, fraction strips, or benchmark equivalent fractions. So 3/4 is less than or greater than or equal to 6/8. You can draw a number line, you can use area model, whatever would help you most. So if we look at this one with an area model, here's my fourths. And I'm gonna have 3 of those fourths shaded. 1, 2, 3, 3/4. Now I notice that 4 is half of 8, so I can just divide all these in half to give me 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8 equal pieces. Now 1, 2, 3, 4, 5, 6 of those are shaded. So yes, these are equivalent. So or equal to one another. All right, let's look at this one as a pizza. 1/4. Pretend they're exactly equal, 4 equal pieces. Or 1/10 of a pizza. Now, I can't multiply 4 times 2 or times 3 to get 10, but I will tell you, just keep in mind, if I divided these in half, now I have 8 pieces. I actually need 10 pieces. Look at even 1/8. 1/8 is only half the size of a fourth. So 1/10 is going to be even smaller. So I can say that 1/4 is definitely greater than 1/10. All right, 3/5. 1, 2, 3, 4, and 5. We're going to shade in 3 of those. 1, 2, 3, and I probably should have made that bigger because now we've got to go to 10th. So we're 5 times 2 is 10. That means I can divide each of these in half. And that's going to be 1, 2, 3, 4, 5, 6 tenths are shaded. So 3/5 is greater than 5 tenths. 5 would be 1 less tenth. Probably need a bigger drawing of that or model as you're doing it. All right, so 1/2 and 4/5. Again, let's try this with a little bit bigger picture with fifths. 1, 2, 3, 2, 3, 4, and 5. 1/2. Oh, I'm starting with my fifths, so let's do our 4/5. 1, 2, 3, 4/5. Okay, now 1/2 I know is going to be right about here. Half of this. There's half, and there's the other half. So 4/5 is shaded all the way over to here, whereas 1/2 would only be shaded on this side. So 4/5 is our bigger one. So 1/2 is less than 4/5. Number line may be your way to go. We didn't practice that. You're going to do that, like I said, next when you go to your visual learning video. You'll do that, and then on page 314, and then you're going to come back and do independent practice, 6 through 15, as well as 23 and 24 on the back.